Hey guys, welcome to my video. Hope you're all doing well. Today I'm discussing another concept and it's a very interesting one. It can be used in three chapters. One is quadratic equations, second is progressions, and the third is binomial theorem. Isn't it sounding interesting? Stay with me till the end of the video. I hope you will definitely like the content. Let's discuss the topic. Coefficient of x bar n minus 2 and nth degree polynomial. Let's see how we can find it out this using a simple example in the beginning. Let's say we need to find out the coefficient of x to the power of 8 in the polynomial, which is expressed in the form of factors x minus 2, x minus 3 till x minus 10. If you look at this polynomial, it is an nth degree polynomial or 10th degree polynomial, and on expanding this polynomial, we will have an x bar 10 term minus some constant into x bar 9 plus another constant into x bar 8, then another constant with minus sign, x to the power of 7, and so on till you get the last constant. So to find out the coefficient of x bar 9, so generally we take it as a negative sum of all roots. So which is basically minus 10 into 11 by 2, which is minus 55. So it's a minus a value which is equal to 55. So a comes out to be 55. And similarly, if I wanted to find out the coefficient of x to the power of 8, that is nothing but product taking 2 at a time. Product of the roots taking 2 at a time. Like I would say 1 into 2, 1 into 3, 1 into 4 like this. Along with that, 2 into 1, 2 into 3, 2 into 4, all this. Then we have 3 into 1, 3 into 2, like this till the end. So this notation, basically we can put it in a sigma notation form. Like if you observe the kind of products what you have, I would write this is equal to 2 times because 1 into 2 and 2 into 1 products are same. But I will put the notation as I less than j, I into j. So that you always write it as one product, but you are multiplying with 2. And I is starting from 1 to 10 here. So this is a kind of notation we can use it to find out this product. And for this, let us consider 1 plus 2 plus 3 plus 4 till 10 whole square, which we can write it as 1 square plus 2 square plus 3 square till 10 square plus 2 times sigma 1 is less than, I is less than, it's just less than here. I cannot be equal to j here, then it won't be the required product. I less than j less than or equal to 10, I into j. So whole of this, let us assume to be some x. So if you're assuming this to be some x, then x I can write it as 1 plus 2 plus 3 till 10 whole square minus 1 square plus 2 square till 10 square divided by 2. So upon simplifying this, and in order to simplify this, we can use two notations. One is sigma n, which is n into n plus 1 by 2. Another is sigma n square, which is n into n plus 1 into 2n plus 1 by 6. So to find out the x value here, n is basically 10 in the previous case. So summation from 1 to 10 whole square minus 1 square plus 2 square till 10 square divided by 2. We can write it as 10 into 11 by 2 whole square minus 10 into 11 into 21 by 6 whole divided by 2. So upon simplifying this equation, you will get the final answer to be 1320. So let's see the generalized way of doing the same thing. In case if we wanted to find out the coefficient of x to the power of n minus 2 in the product x minus 1, x minus 2 till x minus n. So this is basically an nth degree polynomial. To find out the required coefficient of x bar n minus 2, it is nothing but sigma 1 is less than or equal to I less than j less than or equal to n I into j. This is the coefficient of x to the power of n minus 2. And this is equal to 1 plus 2 plus 3 till n whole square minus 1 square plus 2 square plus 3 square till n square divided by 2, which is n into n plus 1 by 2 whole square minus n into n plus 1 into 2n plus 1 by 6 whole divided by 2. So on simplifying this equation, you will arrive to a general expression in n, that is n into n square minus 1, 3n plus 2 divided by 24. So if you're able to remember this expression for the previous question, directly you can plug in n as 10. But I would suggest you to use the concept, and it's a very simple way to apply the concept. So the advanced application of this concept, generally we see it in binomial theorem, where sigma ci cj 0 less than or equal to I less than j less than or equal to n. In case if we wanted to find out this expression, and according to the previous logic, we can write this as half times C0 plus C1 plus C2 till Cn square minus C0 square plus C1 square plus C2 square till Cn square. And let us just revise the results based on it. We already know that C0 plus C1 plus C2 till Cn is nothing but 2 bar n. CR is the basically notation which we write it for NCR. Similarly, C0 square plus C1 square plus C2 square till Cn square. It is 2n Cn. So we will be using these two results here to find out the summation of Ci Cj, where I is less than j is less than or equal to n. This is 2 to the power of n whole square minus 2n Cn whole divided by 2. Further, you can write 2 to the power of 2n minus 2n Cn whole divided by 2, which is one of his standard result here. And there are certain other questions developed from this result. The logic behind this result is very, very simple, but expression looks very complicated. I hope the concept behind it is very clear to you, so that any question comes on this, you will be able to use it with more confidence. So I'll be coming up with some more interesting concepts like this. Bye for now.